Hello, it's Duncan. We developed our temp in bowling simulator with a combination of type and test-driven development. We started by designing types that we felt expressed the domain, and then used tests to drive the implementation of the operations on those types. The resulting test coverage is good, but only consists of examples that we wrote by hand. Given the complexity of bowling scoring, I for one have a nagging doubt that there are edge cases that we haven't covered. Property-based tests are excellent at finding such edge cases. We specify the property of the system, and the framework generates thousands of inputs to try and break it. So stay tuned for the battle between jqwik and our bowling code. We currently have a lot of what I would call example tests. We find an example, a game with Fred and Barney and a frame count of 0, and we assert something about it. And that's the pattern all the way through here, except there are some places where we start with an example and then we move that example through time in some sort of way. But we have to devise these examples by hand, so here we're only testing that we can play a game with Fred and Barney and a frame count of 2. We don't know that our code would work with Wilma and Betty. Property-based testing will generate examples for us, so let's see how far we can get. At the moment we're using JUnit and Kotlin test assertions and also strict. Let's ask AI Assistant to generate code for add jqwik, which is the property-based testing library that I want to try, Kotlin support as a test dependency. Okay, that looks quite plausible, so we'll accept all. Although I do note from the jqwik release notes that we're up to 1.8.3 by now. So ChatGPT is a little out of date. Anyway, let's go off, and next door to bowling tests, we'll create bowling property tests. Add that. And now for jqwik tests, instead of annotating with @test, we annotate with @property. Can we see that? Yes, we can. And we then write a function with some sort of name, a property holds, and that will take some parameters that we'll come back to, but should return Boolean for whether the property does hold. And providing return true, I think we might manage to run this test and have a look. Okay, well the test passed. I notice we've gained a jqwik database here. Let's have a look at what the tests say. It says, warning, a property holds a container without a for all parameter for 1,000 tries. So basically, jqwik called our a property holds 1,000 times, and every time it returned true, because had it returned false, for example, had we said random next double up until 1, if we were to compare that with, say, greater than 0.99, we might expect that to happen in 1,000 runs. Let's have a look. And, well, it did happen straight away. That can't be true, can it? Tries 1. I don't know. Let's find out what that was. Also, println, run that. Oh, I'm an idiot. I should be starting from a small number. So I should be saying, let's only fail if it's not greater than 0.01. That should run quite a few examples. There we go, lots of those, but it still failed at some point. There we go. So far though, all we're doing is using jqwik to repeat a test. What we'd like it to do would be to give us the numbers. So in here we could say for all a double, and now we use that in our test. So instead of taking random of our own, we'll let jqwik give us something that's probably random. So we'll say that this is a double is greater than that. Now then, I suppose a random doubled, about half of them are greater than 0 or 0.01. So let's change this test, and we'll say that it should be that every double is greater than, we'll say -1 e, call it a billion. Let's see how we do. And so the name of this property is that every double is greater than -1 billion. And now if we run this, it's jqwik's job to prove that that isn't true by throwing random doubles at it. Let's have a look. Okay, so let's have a look at what we got. We got 6.3, 3.9, 9. So far all of these it is true that they are more than minus a billion. 0, well, we might expect that to happen sooner or later. We've got a range of little numbers here. They're getting smaller and smaller and smaller and smaller. And sooner or later, you can see we had a failure. Actually, though, we only had a failure after 7 tries. Why is that? Well, if we go back up here, you'll see that after 7, I guess, here, which was less than minus a billion, at that point, jqwik has started looking for the smallest number, or maybe actually I suppose the largest number, that this is not true for. So it started throwing these numbers at it. And you can see as we get down here, it's iterating in on minus 1 by 10 to the 9, until in the end, it's thrown a lot of other examples at us in order to come up with the answer that, actually, it failed with the sample of 1 by 10 to the 9. That was the simplest thing it could fail with. Okay, well, so far so theoretical. How can we use that for our bowling? To warm up, let's start with the first test we've got in our example tests. First one here is a game with no players isn't playable. And that's saying that if we call game with no players, it's a completed game. But the fact is that game has a constructor here that allows a frame count of defaulting to 10, but any number. Here we've shown that a game with no players and 10 frames isn't playable. But the question is a game with no players and 9 frames or 15 frames or 1 frame and so on not playable? You can see the issue here is that we've a test that explains a property, but only tests it for one particular example of that property. So let's take this over to here. And now instead of a double, we'll have the number of frames. So this is a number of frames, and it's going to be an int. Now we can create a game with the number of frames, we're calling it frame count, is a number of frames. And we want it to be true that that's a completed game. That's what we did here. But instead of using expectations, we're going to just return a Boolean. So we can say return game is completed game. Let's try running that. And that passes, good. And if we look at the output, you can see that we tried with 1,000 different numbers of frames. And all of those resulted in a completed game because we didn't have any players. Okay, that's good. Next. Okay then, a game with no frames isn't playable. Let's take that, move it over here, and make it a property. And it wants to return a Boolean. Now in this top test, we held the names of the players, the first parameter here, constant, and varied the number of frames. This time, we're going to vary the number of players and keep the number of frames at 0. So it's going to look like this. And in here, we're going to put the player names. There is just one problem, and that's Varargs here. I think jqwik can create us at for all a list of player names, which is a list of string. But passing it into here as Varargs will be a bit complicated. I think in any case it would be handy to have a list version of this constructor. Now, last episode I made the constructor here an extension on the companion object. And the reason for doing that was that my experience was that if you started a function with a capital letter, like this, that IntelliJ would complain that you shouldn't start a function with a capital letter. Turns out, in fact, that it only complains if you start a function with a capital letter where that doesn't match the name of a type or an interface. I haven't really worked out which yet. If we call that fame, it would say, well, A, it's unused. Let's work our way there. If we rename this to be fame, then that will change the names of these. But you note here there is a warning that it should start with a lowercase letter. But if we call it game, and that matches the name of this type, we don't get that warning. So that would allow us, in fact, be a bit simpler. We could get rid of this odd companion object and just have a fun game. Note that the call sites, all the places that call this, here, for example, the source hasn't had to change, although in fact the thing that it's called has changed, and I think the code will have needed to be recompiled. Anyway, back to game. We want a version of this that takes player names as a list. We've also got playable game here with player names. I think maybe the easiest thing to do is going to be to take this one, make it not Varargs, but rather take a list of string. This one can then call player names to list. There might be somewhere where we're calling playable game directly. Yes, there you are. So this is now going to have to say empty list. That's fine. And the same here. This is list of Fred. Don't mind not having the Varargs with playable game because we have the game function that's more usually used. Okay. And now back to games. We want a version of this that takes a list. So I think if we pull this into a variable and then make this a block body, move this up to there, and now extract this thing. It's also going to be called game. And I don't understand why we have player names twice. Let's just go and fix that up by hand. So this is player names, which wants to be our list of string. Get rid of that one. This is player names. And that we can sort out like bit of a faff. That's an expression. This goes back to being a single expression. And does everything still run? It does. Good. Now, why was I doing that? It was to pass a list of player names into here. Let's try that. Okay, so far so good. It called this one 1,000 times. Let's just see what sort of things it called it with. So we can say also println and run again. And now if we look, you'll see that, well, it turns out the most random strings are Unicode and quite pictogram. But you can see here there's a special case of an empty string and so on. In fact, lots of empty strings. Maybe these are blank, perhaps, don't know. Okay, moving on. I think now we've got this constructor, I will pass empty list in to this one so we can compare them easily. And it's not clear to me we're running all the tests. Now we've got 2 sets, so let's set up a test run of all the tests. Good. Moving on then, this test here can't create an invalid playable game. You can see it does actually have 3 examples, but where we're using a frame count of 0 here, for example, we're only using 1 list here rather than several. This is a bit of a strange test because it's talking to the playable game constructor, which isn't really part of our public interface. But there is this case here I'm interested in, where we pass a frame count of -1 in, and this should apply to our game constructor as well. So I think there's a property of cannot create a game with negative frame count. So here, to be exhaustive, we want to test for different sets of lists of player names and different sets of negative numbers. So we want to keep that, and we want to add a parameter of the number of frames. And now what does it mean that we cannot create a game? Well, it's that it will throw an illegal argument exception. So we'll say return try construct a game. If we manage to do that, then this has failed. But if we get X, which is an illegal argument exception, then this has succeeded. And I need to pass a number of frames into there. Now you can probably see what's going to happen. Half of the ints that are passed into here are going to be positive, and this will succeed. So if I run it, is that true? Yes, it is. It turns out that if we passed the second parameter as 0 in this case, then we managed to actually create a game. So we need to find a way to constrain this number of frames. One way to do it is with an assume, and we can say assume that some condition. So now we can say assume that a number of frames is less than 0, and that will abort any of these runs where the number of frames is not less than 0. It should pass. Oh, that's interesting. Let's have a look. Well, in this case, what it's saying is the first parameter is an empty list, and then we're passing in -1 frames. This feels like an actual bug. Let's have a look how we got there. If we go down into game, then we pass the frame count down. The frame count won't be 0, so we pass a playable game. Playable game, its constructor here says player names map, playable line, it, and frame count. Playable line here, this is the place where if you have negative frame count, we expect it to fail, because you can't create a list with a negative number of frames. But block for this map won't be invoked when there are no player names. So we'll never hit the constraint in playable line that caused the illegal argument exception to be thrown. So jqwik is making us consider which of two behaviors we want. Do we want to say, well, there are no players, so it doesn't matter that frame count is negative? Or do we want to say, well, there are no players, but we're going to fail because you pass an invalid input for the number of frames? I think probably our software would be less confusing if it always failed for a negative number of frames. So where can we put that constraint? I think the answer is probably we should do it in here so that it also applies to playable game. In order to do that, we need to find a way of making this expression into a multi-line thing. And I think what worked for us before was to say unit.run, and then we can put the require in here. Frame count is greater than or equal to 0, otherwise cannot create a game with a frame count of frame count. Does that get us running? Oh no. Well, I think it shows why we need tests. Let's have a look at the failure. It failed for an empty list and a negative frame count. How did it manage to fail? Let's see whether we can work it out. Let's look down through our game constructor. Here we actually specifically say player names is not empty. If the player names is empty, we go straight to a completed game. Okay, I think we're in a good old-fashioned compromise territory here. I can't think of any good way of funneling the frame count into playable game in order that this require is hit. But I don't really want the require in both places. I think I'm just going to say that we should make this a block body. We should move this require up into there. And say that if you call playable game directly, then you don't see this behavior. So we can take that out, return to there. Is that okay? Still no, oh dear. But now you see we've failed a different test. We're now failing a game with no players isn't playable. Why is that? Well, here we are. Game is now checking that number of frames is not negative, but jqwik is passing a negative number of frames in here. Well, I suppose that's all right. We can fix that with an assume. So we put that in there, and now things are still not right. Oh, I'm an idiot. In this case, we need the number of frames to be greater than or equal to 0. Can we finally get there? Yes, we can. Having said that, of course, jqwik is throwing random sets at us, so it is just possible that it will fail another time. But I'm quietly confident about that. Now, a problem with what we have now is that this assume will be throwing away half of the number of frames that's passed into us. I suppose given this greater than or equal to 0, technically almost half. So instead of assume, we can use a provider. Let's see whether ChatGPT can generate one for us. So we say generate code, and I want write a jqwik provider for integers greater than or equal to 0. Okay, let's see what we've got. It's changed a number of frames to this for all with a name, non-negative integers. There it is. And down here, oh, it's actually done negative integers for us as well. Well, that's nice, thank you. And it's added non-negative integers. They are an arbitrary int, and they're defined to be integers between 0 and int max value. And here we've got integers less than or equal to -1. You know, that all seems really plausible. I'm going to accept it all and run. Well, there you go. So we can use these providers to affect what values jqwik is injecting. That seems like a good place to check in to me. Let's see what changes we've made. We've got this unversioned jqwik database. That's interesting. I suspect that we should add to git ignore. Our bowling tests have changed. Let's have a look. Why? Because we changed the interface to playable game. Our build has changed to reference jqwik. Game has changed, and that's because we've added this player names that takes a list of string, and that's just more convenient for software to call rather than the Varargs, which is more convenient when humans type things in. Okay, I think that's a good change, so we'll commit that with introduce jqwik tests for creating games. And there are a couple of issues. Let's just have a look. That's interesting. IntelliJ doesn't know that provide means that this function will be called. I think there's a way to add annotations to the list that makes something used. Let me see if I can work out how to do that. It's sort of hidden in plain sight. Here you can say suppressed unused warning if annotated by jqwik API provide. So now if we build, that warning's gone away. Good. Okay then, before we get on to actually playing a game, we have one more test here. A game with players is playable. Again, this has two examples, but they're just a single player and two players, and they're not testing the frame count. Anyway, let's take that, copy it over into here, and we'll say that this is a property, and in the same way here, we want a list of player names. And in this case, we do want it to be playable, so we want positive integers. So let's write ourselves one of those, which is positive integers, and that's all integers that are greater than or equal to 1. So now we want to throw positive integers for our number of frames, and we should be able to say that return game, a list of player names, and a number of frames is playable game. And we'll fix this up to return a boolean. Let's run that. Good. I must say that I'm suspicious because I haven't specified that this list can't be empty. And I would have thought a game with an empty list of player names, no matter how many frames, should not be a playable game. In fact, I thought we had a test here that showed just that for an empty list. Let's just print out whether this list of player names is empty and run just this test. Aha! Well, that's interesting, because as soon as it was, we failed. Look there. But why didn't we fail before? Let's try running all the tests. That's very suspicious, isn't it? What did we actually run? Oh, am I running the wrong thing? I am. Dope. And yet, there we are. I do not know what's happening now. Look at this, we don't appear to be running all the tests in bowling property test. Why not? Well, I wonder whether in the edit I'll see how I mess that up. But we do seem to be in a state now where we're running everything I expect to run and getting the results I think we should be getting. So let's take this out. Run. Good. And now, given that most lists of string will not be empty, I think we can just solve this problem with assume that a list of player names is not empty. Good. That's interesting. Rerunning the tests has just run some of those tests. Aha, there we go. Look, Java heap space. Finally got to the bottom of it. And in fact, it was in the back of my mind that we could be passing 100,000 frames into here, whereas a real bowling game is limited to 10. I'm glad we got to the bottom of that, and we can solve it by saying, in fact, our positive integers here, what we really want here is positive integers less than 11, say. So we can say here between 1 and 10. And we'll just check the definition of that. That's a min and max, so it's not actually between, it's including the z point. Good. So this, I think we'll say, is valid frame count. We can use valid frame count in there and in I was going to say and there, but I think in fact we still want any non-negative integer here because we're passing an empty list and we always want to be a completed game. So I think that's fair enough. Just check everything's fine. So valid frame count seems to be a good thing. Let's run that. Good. And we'll check that we're running all of our tests. Splendid. Finally, one little Kotlin tidy. jqwik provides int extension functions for int.any, and then we can put in a range. So we can say int any, and this will be 0 to int max value. If we import that, that would tighten this up quite nicely. This, I think, then is int.any from int.min value to -1. And valid frame count is int.any between 1 and 10. All good. All good. Except that if we'd messed this up, we might now be injecting fewer values into our tests. As a Kotlin developer, there's something a little bit irritating about these annotations and the fact that this thing has to line up with this thing. I'm sure a pure Kotlin property-based library would be based more around first-class functions, but I don't hate it, and it is quite expressive. Okay then, given where we are, I think probably that's only an amend commit. We've gained a misc.xml. That's where we mark the annotation. Okay, let's just amend commit that. One analysis point, which is that IntelliJ is still lying to us about current player. Well, testing our game creation has been a good way to warm up on jqwik, and I think the formalism has certainly led us to improve our interface a little bit. Of course, the really interesting properties, though, are those that apply to games as we're playing them. If you've experience in property-based testing and can think of good properties of an in-progress bowling game, then please let me know in the comments below. If you want to see the sort of thing we come up with, then please subscribe to the channel so that YouTube will tell you when the next episode is available. I'm sure there's a like button somewhere that you can press if you want to give me a little dopamine hit. Or even better, you could buy the book that I wrote in that price called Java to Kotlin, a Refactoring Guidebook, details of which are in the show notes below. Thanks for watching.